In 2.1, we're looking at increasing, decreasing, constant functions, maximums, minimums, and piecewise functions. So let's look at some examples. So the first problem wants us to locate when are we increasing and when are we decreasing. So I'm going to draw some lines just to break our graph into pieces so that we can kind of see where these sections occur. And when we're asked to list where are we increasing or decreasing, we're asked in which parts of our domain are we doing these things? Are we going up, down, or being constant? So as we compare x values that are beside each other, what is our graph doing? Is it going up, is it going down, or is it staying the same? When we read from left to right. So in each section, as we go from left to right, are we going up, are we going down, or are we constant? So if we break it up here, and here, and here, and here, no, those are kind of close together. Let's see if I can change colors. So this first section of the graph, as we read from left to right, that's going up. So that section is increasing. The next section of the graph, as we go from left to right, is going down, so it's decreasing. The next section is staying the same, so it's constant. Then this section is back to going up, so it's increasing. Let's change color there, so that's increasing. And then this last section is staying at the same height, so it's constant. So that's the sections that are going up, going down, or staying the same, but how do we describe those? So let's start out with increasing. So we start out way out here at negative infinity, and as we go from left to right, starting at negative infinity, the graph, this whole piece of the graph is going up. Um, Going up, going up, going up, going up. So as we start way at the left end out here, negative infinity, we're going up until we get right here. When we get right here, we stop going up. So to say where does it stop going up, we don't list the y value. We're not asking how high it goes. We're asking as we put in x value and another x value and another x value, when is our answer going to stop going up? It's going to stop going up when we get to an x of negative 7. When we get to negative 7. If we pick an x value after negative 7, then we're going to start decreasing. So from negative 7 until we get to this x value, if I do like negative 7, negative 6, negative 6.5, negative 6.8, and then I'm sorry, I gave you the wrong numbers there. If I do negative 7, negative 6, negative 5.5, negative 5.1, as we get close to negative 5, our graph is going to be going down. It's going to be getting lower and lower and lower. So those are the sections of the domain. So then our next section that starts at this x value and goes to this x value is constant. So we're constant when our x is negative 5 going all the way to negative 2. And notice I'm putting these in parentheses and not putting brackets around them. So these are intervals, but we don't include the edges, and we're not going to get into all the details of that. I'll just say this. For negative 5, would we include -5 in the section where it's going down, or would we include it in the section where it's constant? Well, that one point, if you don't have the points around it to compare it to, one single point is neither going up or down or whatever. So we just put a parenthesis on the edges to not talk about that one single point. So our next section, going from -2, this x is -2, this x is -1. So from here over to here, we're going up. So we're increasing from -2 over to -1. And then our last section here is constant. So starting at -1 and going to positive infinity, that's where we're constant. So if we have more than one interval, we put a u in between those. So just a reminder, these are x values. At what x values are we going up? At what x values are we going down? And between what x values are we constant? So we're not answering how high we go or how low we go. We're just asking in which section of the graph are we going up, down, or constant. So this section, which goes from -infinity to -7, goes up. From -7 to -5, down. -5 to -2, constant. -2 to -1, up. -1 to infinity, constant. So if we were to combine these intervals, that would include the whole domain except the transition points. If we put our intervals in order, -infinity to -7, and then -7 to -5, and then -5 to -2, and then -2 to -1, and then -1 to infinity, that basically is everything from -infinity to positive infinity except those transition points. So these are x values that describe which sections are we going up, down, or constant. Generally, people can tell me where it's going up or where it's going down, but the problem lies with how they describe it. If I just ask you to put your hand or your finger on the place of the graph where it's increasing, that's not a problem. But every now and then, actually describing that in interval notation is an issue. So that's what we're doing here. So the next problem asks us the same thing, but it also asks us for relative maximums and relative minimums. So we have a peak here. So the maximum value there is -1. If we're asking how high something goes or how low something goes, that's a y value. Y values tell you how high or how low. So this goes up to -1. This one is a trough. That's a minimum. So that goes down to -33. Now, often I need to know at what x value does that occur. So we have a maximum of -1 when x is 2, and we have a minimum of -33 when x is 10. Notice we said relative max and relative min because there are lower points on the graph, but in this area there's nothing lower. This graph keeps on going up, so this is not the highest point forever, but in this section it's the highest point. So that's the maximum and minimums. Now let's talk about again where are we increasing and decreasing. So we have a transition point here and a transition point here. So our graph is broken into 3 sections. This section, and this section. So over what interval is our graph going up? So going from negative infinity to 2, our graph is going up. Going from 2 over to 10, we are decreasing. We're going down. And then starting at 10 and going to infinity, then we're going back up. So notice how this includes everything in our domain except those transition points. So we've just broken this up into sub-intervals, sections. So this section, negative infinity to 2, increasing, 2 to 10, decreasing, 10 to infinity, increasing. So we're increasing from negative infinity to 2, union 10 to infinity. And we're decreasing 2 to 10. The last topic in this section deals with piecewise defined functions. And if we look at this particular graph, this is a piecewise defined function. It takes different equations to describe different parts. This part of the graph is a constant. It would be given by the equation y equals, let's say, 2.5. Y is always the same here. This is a straight line with a positive slope, so it would take a different equation to describe this line. Here, this is a constant, so y equals -1 here. And then we have what looks to maybe be an upside down parabola, so we have a quadratic function here. So it takes different equations, different functions to describe each of those pieces. So this is how you would describe that. Instead of writing 4 different equations or having 4 different functions, it would take 4 different formulas, but we could consider all of that one function. Because if we use our vertical line test, this is a function. It passes the vertical line test. So we could give it one function name, but we would have to describe each interval with a different formula. So first of all, we want to, how do we interpret these things if we have that function? So to evaluate g of -1, -1 is our x value. So if our x value is less than 4, we use the top formula. If our x value is bigger than 4, we use the bottom formula. So since our x value is less than 4, we're going to use the formula that says take our x and add 6, where our x is -1. So -1 plus 6 is 5. So when x is -1, our y value is 5. Notice we did not plug -1 into both formulas, only the one where our x fit. Our x is in the interval that's less than 4. Let's do the 8 next. This time the x value is 8. 8 fits in that bottom interval. 8 is bigger than 4, so we use the formula 9 minus our x. So g of 8 is 9 minus 8, or 1, so that gives us the ordered pair 8, 1. For the answer, it's probably just going to ask you for the output, the y. Now let's do g of 4. So g of 4, 4 is in this one, because when we look at less than or equal to 4, 4 is equal. So if our x value is equal to 4, it's the top one. So our formula is our x plus 6. So when we do 4 plus 6, we get 10. So that's our answer for G of 4. And the last problem that we want to do is we want to graph a piecewise defined function. So I'm going to pull up some graph paper. And let's put that back over here. So let's just do this. They want us to graph this. So we have 3 different sections. So for reference, our transition points are x equal negative 3. So here's where x is negative 3. 1, an x value of 1. So that breaks our function up, our interval up. So we have x's that are less than or equal to negative 3, between negative 3 and 1, and then bigger than 1. So that's our 3 sections. So let's do the middle one first. F of x, or you could say y equals negative 3. Notice there's no x in that formula. That means y is always negative 3. And when is that? If we're between negative 3 and 1. So when we're between negative 3 and 1, our y is negative 3. So our y value is down here at negative 3 anytime we're in that middle interval. So that's just a horizontal line. Notice this interval does not include negative 3 because there's not a line under it, nor does it include 1. So to show that we don't include the ends, open circle, open circle. Now let's do the top one. Y equals x minus 2. So we could do this a couple of ways. We could use the slope and the y-intercept to figure out where our line needs to be. We would just need to make sure that when we actually drew it, we didn't include it in this particular section. So if we looked at the slope and the y-intercept, our slope is the coefficient of x. Our y-intercept is negative 2. So the y-intercept is here. And our slope is 1. So I'm going to use little yellow dots. I guess I could change it here. Or let's use little green. So our y-intercept is here. And if we have a slope of 1, that means rise 1, run 1. If our slope is 1, that as a fraction is 1 over 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. So that line, if we draw a line through those points, does this. Well, our line actually only exists for x values that are less than or equal to negative 3, so in this first interval. So those dots tell us where we can put our straight edge, but we're only going to draw that over here. So that's one way that we could do that. That's not the only way. I'm going to show you a different way we could do that with the last one. But we could put our y-intercept and our slope to give us a straight edge, and then we can draw our line in the correct interval. We include negative 3 for that part of the graph. So at negative 3, we close that in, and then we put an arrow there. So for the last part of the graph, we're at y equals negative 4x. Again, that's going to be a straight line. It's not quadratic. Our x is to the first, and that's going from 1 to infinity, so from here over. So another way we could do this is we could just do some test points in this interval. So let's start at 1. If we take that formula and we put a 1 in for x, when x is 1, we get -4. So 1, -4, and there is a point there because an x value of 1 is included in that part of the graph. Let's put in another test point. Let's try 2. So when x is 2, what is our y? So when x is 2, we're using that formula. -4 times 2 is -8. So when x is 2, we're down here. It's a straight line, so we can draw a line through those. We already said that we include this point because for the third interval, 1 is included. And then we put an arrow there to show that it keeps on going. We could have used the slope and the y-intercept. Our y-intercept on the third one is 0, and our slope is -4, so down 4 over 1, down 4 over 1. And when we put our straight edge through those points, we would have just drawn it in its interval. So different ways we could draw those lines.